In the previous video of this series, we examined the definition and characteristics of two compound inequalities, the AND compound inequality and the OR compound inequality. Now that we know their definitions, characteristics, what the solution space for each one looks like, we're going to actually practice solving these compound inequalities. So if we look at the first example, we have negative 18 is less than 5x minus 8, which is less than 17. This is an example of an AND compound inequality. We can see it set up where your variable expression is in the middle of two inequality symbols. And so what we're going to do is focus on the middle. We're going to focus on how would I isolate the x value in the middle of this compound inequality statement. And what I would do first is get rid of this minus 8. And so that's what I'm going to set up. I'm going to add 8 to both the right side and the left side. Whatever you do to the middle to isolate the x, you have to do to both outsides. And so if I take a look, negative 18 plus 8 is negative 10. So I have negative 10 is less than. By adding 8, I'm now left with just the 5x, which is less than 25. And so now the same idea. What am I going to do to get this x by itself? Well, here I would get rid of my coefficient of 5 by dividing by 5. So if I do it to the middle, I have to do it to both outsides. So divide by 5, divide by 5. And you're left with negative 10 divided by 5 is negative 2, is less than. We divide by 5 to get rid of the coefficient, so it's just x. The x is isolated now, which is less than 25 divided by 5, which is 5. And so here is your solution for this compound inequality. Negative 2 is less than x, which is less than 5. To graph this on the number line, we're going to go very, very basic here. We're not going to do tons of intervals. We're just going to go and write down the numbers we're using. And so negative 2, and then I'll put the 5 over here. And what we do is we identify what type of circle will be used at each number. And so since it's negative 2 is less than, that would be an open circle. Here it says x is less than 5, and so that would be an open circle on 5. Your x, your solution, is between negative 2 and 5, and so your solution space on the graph would be between negative 2 and 5. And so there is the graph and the solution for the compound inequality. So that is an example of an AND compound inequality. Let's look at an OR compound inequality. We can tell, first off, that this is an OR because it's separated by the word OR for it. This is very simple. What you do is you work with each inequality separately. So I have 2x minus 7 is less than negative 19. So I would add my 7, and that would cancel out the negative 7, and I'm left with 2x is less than negative 12. And then what I would do is divide everything by 2. And that gives me x is less than negative 6. So that's the first part of our compound inequality. I still have to work with this 4x plus 3 is greater than or equal to 11. To solve here, I would get rid of the plus 3 first by subtracting 3 from both sides. And what that allows me to do is to make the next statement 4x is greater than or equal to 8. And then I would divide everything by 4. And that gives me x is greater than or equal to 2. So my final statement is x is less than negative 6. We have the or, we're just going to bring down, or x is greater than or equal to 2. So that is my solution compound inequality. Now I'm going to graph, and we're going to do the same thing. Let's just put negative 6 here, and we'll put positive 2 here. Same idea, you need to determine if you're going to use open or closed circles. Since it's less than negative 6, that's an open circle. Since it's greater than or equal to 2, that is a closed circle. Here it says x is less than -6, so we want the smaller numbers like -8, -10, -12, so this arrow goes to the left. Greater than or equal to 2, so that's like 5 and 9 and 11, so we're going to go to the right. And there is the graph of the solution space. So these two were very simple inequalities to work with, and an or. So let's do two more examples, problem 3 and problem 4. We can look at problem 3 and see that this one is also an and compound inequality, just like our first one. And I'm going to set this one up for those who struggle visually on what to do. What we want to look at is how to make it easier for you. And the easiest way to do that is if you struggle with knowing what you do in the middle, you do to the two outsides. For some students, it helps to kind of just put some dashed lines. And what that does is it shows you visually there are three parts to this compound inequality statement: the middle and the two outsides. So you can focus on the middle just like what we did before. And how would I isolate this x? I would subtract 8. Well, now you see this -8 is all by itself in the middle, and you know with solving equations, whatever you do to one side, you have to do to the other. It's just now there's two outsides, and so I'm going to put a -8 here and a -8 here. So visually, this kind of helps some students with the setup. 14 minus 8 is 6. I'm going to have less than or equal to. The positive 8 and negative 8 cancel each other out. I get 3x, which is less than 2 minus 8 is -6. Same idea. I still can drop down the dashed lines if I need to, but we want to isolate this x, so I would divide by 3. Well, if I do it to the middle, I now see, wait a minute, there's two outsides. I visually need to put it there as well to keep the equation, or here the inequality, balanced. So 6 divided by 3 is 2. So 2 is less than or equal to, the 3 and 3 cancel, so I get x, which is less than -2. And so for this example, what we want to look at is the solution space. And this is a unique setup for it. We're told in the first example, which is very easy, and we saw the guided example previously, that you set your two outsides and you put your solution in the middle. But you have to be able to examine your problem. You don't just do things blindly. Read the statement. 2 is less than or equal to x, which is less than -2. Well, if I look at this, and I were to graph this, and just follow along, don't write this down for you, but if I were to do this, I'd put a 2 here, and I'd put a -2 here. And my solution would be between them. If you first look at this, does this visually even make sense on a number line that your 2 is to the left of -2? And that shouldn't make sense for the setup. And so this, right off the bat, should kind of be making you think, what's going on here? Now look at it separately. I'm going to split this apart. This says 2 is less than x. So I'm going to split these into the two inequalities, which really, remember, you always put your variable on the left side. So we flip it. Means x is greater than or equal to 2. So I'm gonna graph them this way. Maybe that will make it a little bit easier. And so I'm going to put my 2 and my -2 where they should be. The 2 should be on the right, and the -2 should be on the left. So if x is greater than 2, then okay, greater than or equal to is a closed circle with an arrow to the right. If I were to focus on the next one, it says x is less than -2. Well, that's an open circle and an arrow to the left. And so you may think, well, there you go, there's your graph, you're done. But you need to remember, what is the definition of an and? Don't just jump in and, oh, I'm done, I got the graph, I got x, it's all set. Understand your meaning, interpret your meaning. And is the overlapping of your two simple inequality solution spaces. So the question is, do these two graphs overlap? And they don't. Because if the number is greater than or equal to 2, and at the same time, and that's what you need to realize, not only is it greater than or equal to whatever value x is, at the same time, that number that's greater than or equal to has to be less than -2, which cannot happen. So therefore, This is one of those rare 1% type of situations where we can say there is no solution. There is no number that exists that is greater than 2 and at the same time being less than negative 2. And so the answer is no solution, which means there is no graph that can happen. And so don't go into every problem thinking this is a trick problem, it's going to be no solution. The reason why, and one way you can know that there's a chance for no solution for an and compound inequality is right here. You should numerically have this make sense, that the left side number is lesser than the right side number. It's going to be less than that right number. And here, when I put down 2 here, negative 2 here, it didn't make sense on how the number line is set up. So that should put a red flag. And so then I separated it and saw there's no number that's greater than 2 and at the same time less than negative 2. So I jumped to no solution. So it's a trick one. Hopefully it makes sense. Let's look at the next one. This is an or compound inequality. We can see it's split by that word, so we work with them separately. So here what I'm going to do is I'm going to subtract the 12 to isolate the negative 7x. And so I get negative 7x is greater than negative 21. Next, I would divide both the left and the right side by negative 7. And so listen to the words I use. I divided by a negative 7, which means I flip my inequality. So negative 21 divided by negative 7 is 3. I really have x is less than 3. And then I work with the next simple inequality over here. I would subtract 11. And I'm going to get here 3x is greater than 23. And then I would divide both sides by 3. And that's going to give me x is greater than, I'm going to leave it in fraction form, 23 thirds, which we know 24 divided by 3 is 8. And so really, I'm going to write this off to the side. It's 1/3 less than 8. So that means, 7 and 2/3, 7.6 repeating. And that's going to allow me to graph that in the number line. It's okay, it's a fraction. I mean, fractions are numbers, so we can still use it. Let's put the or there, and there is our solution for our compound inequality. We're going to examine that first, though. If I say x is less than 3, so let's put 3 here. Let's make sure it makes sense. And 23 thirds is between 7 and 8. And so I'm going to approximate its location for it. I have less than 3, so that would be an open circle, arrow to the left, greater than 23 thirds, and so that'd be an open circle. Here it's about close to 7.6 repeating, and then an arrow to the right. Or compound inequalities are the combination of the two, and so it's both of them graphed on the same line. And so this is our solution space for it. And so our first two were pretty basic, and you saw our next two were a little more complicated. We saw an example of how an and can have no solution. And we saw that or compound inequalities, you may get a fraction, but what you do is estimate its location on the number line. So I hope this helps you with your compound inequalities and how to solve the two different types before you move on to the next part of the series.